Okay, this video is going to share the story of why Niels Bohr in the early 1900s decided to modify Rutherford's atomic model of matter. Now, as you watch this video, I want you to be careful to pay attention to the right things. And that is, we want to watch carefully, what did Bohr observe? From what he observed, what did he infer? And from his inferences, how did he modify the model? That is Rutherford's model. That's the chain of logic that we want to pay attention to. All right, first some things that Bohr knew about the atom that helped him to understand what he was seeing and ultimately revise Rutherford's model. First, he knew that light consisted of waves, and each color or wavelength of waves was a different energy. We've seen that short waves like this equal higher energy. And those are generally blue or bluish or violet. Longer waves equal lower energy, and those are generally in the red part of the rainbow spectrum. Second thing he knew was that electrons are the part of the atom that's responsible for giving off light. And the third thing he knew is that when electrons are given some energy, they can give it up by giving off light waves. So that's why the electrons decide to give off light waves, is if they're given some extra energy. So what did Bohr think about? Well, he was thinking about the spectrum or the pattern of light waves that you get when you have light from just a particular element. For example, in a neon sign like this, the open part here is glass tubes filled with the element neon, and you give it energy by putting electricity in. And this tube might be filled with nitrogen, and it gives off kind of a different color light. But both of those colors of light are actually made up of a whole bunch of individual wavelengths. So he had an experiment something like this. He had a tube like one of these, ran some electricity through it, sent the lights like this, and then through a prism, which we're familiar with being able to separate out that light. And he saw that while he got kind of what he expected, which is some low energy and some high energy waves, he didn't get a continuous set of waves. He didn't get any yellow or anything like that. Looked at it from the end, it would look something like this. In other words, he saw only very particular sorts of wavelengths of waves, not just any wavelength. And so he began pondering. He said, well, there's nothing in Rutherford's model that would necessarily restrict the electrons to giving off only those sorts of waves. No matter what he did, whether he ran this hotter or colder or under more or less pressure or whatever it might be, he always got those four same waves. So again, what could possibly account for that? Well, let's take a look at Rutherford's model, as Bohr might have, and said, well, the electrons are all the same as each other, and they're all zipping around the nucleus, and there's nothing different there. They're all sort of going in random orbits. But I suppose what he might have thought is, well, what if we did something like this? We put the nucleus here, this core of positively charged protons, and then what if we did something like this? We have the electrons, instead of orbiting kind of randomly, we put them in very specific, okay, this would be better if I could draw good circles, but I can't. And so we have an electron here, an electron here, and an electron here, and they're in very specific orbits. And they can't be in an orbit somewhere in between. They can't be in an orbit somewhere in between like that. They could only be in this orbit, or that orbit, or that orbit. And really, he thought about these orbits as related to energy. So orbit equals energy. And so he was thinking, well, if they can be in only particular orbits, then they would give off only particular energies, and that would account for why I see only particular waves of light. And so this is Bohr's model of the atom. Essentially, take Rutherford's, and instead of having random orbits, have very particular orbits. Now, let's take a little bit deeper view of Bohr's thinking on this matter. All right, here's a much nicer picture of that. So this is the way that Bohr probably imagined this to happen. So when we run electricity through, we might energize this electron right here. And this electron actually might jump up to this orbit, a higher energy orbit. But then, as electrons tend to do, it would tend to fall back to this orbit, nowhere in between, just here or here. And in doing so, it gives up a certain amount of energy equal to whatever the difference is from that energy to that energy. Well, then maybe that's a very little bit of energy, so that would correspond to that wave. Now, you might get an electron moving from this orbit or this energy level up to this energy level when you electrify it, put electricity through, and then that would jump back down. Well, that maybe is a little bit more energy, and that might correspond to a little shorter wave like that wave right there. But again, it couldn't jump somewhere in between. It couldn't be given a random amount of energy, and it couldn't give back a random amount. Only that specific jump there. Let's look at that in one more case. It might have an electron that would jump from here all the way up to here, and then fall back again. And that would have even a higher energy, and that might correspond to that one. And we could go on, and we could have a jump from here to here and here to here. But regardless, you'd have very specific sorts of waves given off because of the very only specific energy levels that could be jumped between. That's more or less how Bohr thought about it. And because he had this observation that there was only very particular waves, only certain waves, that meant for him only certain energies, and in his mind that led to a modification, which means that the orbits were specific and only certain orbits, and jumping between those orbits gave very particular sorts of energy give-backs in the form of light. So this is Bohr's model right here, and it's a very simple modification of Rutherford's model. He just simply put the electrons in very particular orbits, but at the same time it's kind of a big jump because at that time there was really no reason, no laws of physics that would say that they could only have certain orbits or certain energies. So in some ways it's kind of a big jump, but in some ways it's just a little jump because, again, all he did was make very specific orbits. Now, if you didn't follow some of this bit about how the electrons give off just certain waves of light, that's probably okay. It's more important that you know he observed the very specific waves of light, and from that the electrons needed to be put in very specific orbits. All right, so that's the story of how Bohr modified Rutherford's model to take account of the experiments that he carried out.